Assalamualaikum student. In this video we will discuss about the Newtonian perspective regarding the gravity. But before going into the detail, we would discuss about the gravity, and we would try to define the gravity in the simplest possible way. So let's look at what is the gravity. First of all, let me tell you that gravity is one of the four fundamental forces of the nature, and the other three fundamental forces are weak nuclear force, strong nuclear force, and electromagnetic force. So gravity is one of the fundamental force. And now going into the detail of regarding the Newton's law of universal gravitation, or what was the Newton's perspective regarding the gravity. In the previous video we discussed about the history of the gravity, and in this we would discuss about the Newton perspective. And we also know that before the Newton there were also few other scientists who also worked on the gravity, but the Newton did it some greater extent. So let's start with the strong observation and the amazing observation that one day he was sitting under the apple tree. He observed that the apple fall on his head or front of him. And about this incident, I have also searched on the Google and on many other sites, and I have found that it is actually a true incident. But we are talking about 1687. We can't say everything with the 100% accuracy, but although we can say that he was sitting under the tree and he observed the falling of an apple. So what a common man would have done, he might have or she might have ignored it, but he thought that why the apple is falling downward, why the apple does not go up. This is actually one it is actually the one of the greatest question that has ever been asked, and at the time it was the really greater question that make him wonder that why what is the thing that is responsible for fall of an apple. Then for this he worked continuously, and then he gave his famous law of universal gravitation, universal law of, or you can call it universal law of the gravitation, in its book of with the name the Principia. So you can see this is the equation of Newton's law of universal gravitation. F is equal to g m1 m2 upon r square, where m1 m2 are the masses of the object, and F is the force of attraction between them, and r square is the square of the distance between them. So now let's look at this law. What this law actually tells us, what is the gravity. So this law tells us that there would be the force of attraction between any two masses in this universe. If you are taking means, you can see this. Let me tell you. Let's see this. There are so many books present here and in the haphazard location. But see this. This is the glass. This is the book. These are the two bodies. But there would be some force of attraction between this mass and this one, and which will be responsible. The force of attraction would have the direct relation between the masses of the glass and the book, and it would have the inverse relation with the distance. Is it, are they closer, are they far apart? So the Newton meant that, or Newton can if we talk further about the Newton, that he said that there would be the force of attraction between the two masses, every two masses in the earth. And he said that the force which is responsible for the falling of apple on the ground is the same force which keeps the moon in its orbit, and it is the same force which also keeps the earth revolve around the sun. And he calculated the various actually not he, but various other scientists, with this famous equation F is equal to g m1 m2 upon r square, calculated the various distances, are the distances between the various planets. So the Newton's perspective was clearly that the gravity is the force, and it causes objects to fall or to attract towards each other. And in the coming lecture, we would discuss about the Einstein perspective, and we would also go some of the basic regarding the quantum mechanics, what the quantum mechanics says about the gravity.